Hey guys, so in today's lecture of ECM, we are going to start a new topic in energy efficiency in thermal utilities and system. So a new system which we are going to discuss is steam system. So how we can conserve energy in steam system. So before finding the opportunities where we can save the energy, we need to understand few aspects of steam. So starting from the properties of steam. So first, so this is the syllabus. So what topics we are going to discuss is properties of steam, then assessment of losses, that where there are losses, then steam trapping, then condensate and flash recovery systems, how we can recover the condensate and flash steam, then identifying opportunities for energy saving, and then steam utilization. So these are the topics which we are going to discuss in this steam system. So we'll start with properties of steam. So properties of steam. So in that we'll see some basic definitions first. So if heat energy is added to water, so what will happen? So the temperature of that water will rise. Okay, so the heat energy required to raise the temperature of the substance is called sensible heat. It's called sensible heat. Sensible heat means the heat, the amount of heat required to raise the temperature of the water. That is sensible heat. So that is one definition which is important. Then second, if we add further heat, then the liquid phase of water is changed to steam. So if phase change occurs, so from liquid to steam, if water is changing its phase, where no liquid phase exists, so when it is converted into the steam, so the liquid phases disappear. So this process is called change of phase of water from liquid to gas, and the corresponding heat, as we know that when phase change occur, so the temperature remains constant. So if uh, the heat required to change this phase of water, so where this heat is going, so it is going in changing the phase, so that heat is called latent heat. So if it is for water, then latent heat of water, and etc. Then the temperature at which the water boils is called boiling point or saturation temperature. We can also call it saturation temperature, which increases as pressure increases. So if pressure increases, then the boiling point or saturation temperature increases. So boiling point is not a fixed quantity. So it keeps on changing or depending on pressure. So with any further addition of energy, some of water will boil off as a steam, as we know that. Then next definition is degree of superheat. So with if we further add the heat at constant pressure, so the steam becomes superheated. So steam will become superheated. So after becoming steam also we are adding more heat. So the temperature of the superheated steam will increase. So it is expressed in terms of degree of superheat. That is called degree of superheat. So there is a difference between the superheated steam temperature, that is T sup, minus saturation temperature, that is Tsat, that is boiling point. Okay, so this is called degree of superheat. So these are the main definitions which we need to understand for the steam. Now let's move to assessment of steam distribution losses. So now we will assess the steam while steam is being distributed. So what type of losses occurs? So steam distribution system is essential link between steam generator and steam user. So steam generator we can call it as a boiler, and steam user we can call it as a turbine. So steam generator is boiler and steam user is turbine. So whatever the source, an efficient steam distribution system is essential if steam of right quality and pressure is to be supplied in right quantity to steam using equipment. So if we if the turbine is getting right quality and quantity of steam, then we can say that the steam distribution system is efficient. So the installation and maintenance of this whole system are important issues and should be considered at design stage only. So what are the losses during this distribution of steam? So as you can see, there are three pressure loss due to condensate of the steam. That is, the steam gets condensation, so its temperature reduces and converts into water. So that is one loss. Then due to friction, so when steam comes in contact with the pipe pipe surface, so it will create some friction, and also the there will be an internal friction also, viscosity. So that friction will also reduce the loss. Then improper sizing of pipe. So if the pipes are not sized properly, that is, if pipes are sudden enlarged or sudden contraction is there, then also pressure drop can be observed. So we'll see one by one. So first is pressure loss due to condensation of steam. So as steam condenses in the process flow is induced in supply pipe. So condensate has very small volume compared to steam. So steam has very great major volume while condensate is very small volume, and this caused due to pressure drop. So which causes the steam to flow through pipes. So there is always a pressure drop, then and then only the steam can flow. But due to this pressure drop, the steam is getting condensate. So the steam generated in boiler must be conveyed through pipe work to the point where its heat energy is required. So initially there will be one or more pipes or steam pipes which carry steam from boiler in general direction of steam using plant. The smaller branches pipes can then carry the steam to individual pieces of equipment. So if there are smaller branch pipes, so if branches are less, then the loss will be less. So that is loss due to condensation of the steam. Then loss due to friction. So working pressure of steam distribution system depends on two factors. So one is boiler pressure, working pressure of boiler, and minimum pressure required at the plant. So as the steam passes through distribution network, some pressure is lost due to friction resistance within the pipe wall as well as due to condensate within the pipe work. So if this condensate has occurred, so this can also create a friction to the steam. So proper allowance should be made for this pressure loss. So we need to make some allowance for this loss occurred. So what are the allowance we are making? So uh, that factor will be considered while designing the stream distribution system. So that will call as head loss, HF. Then next loss is loss due to pipe redundancy. So all redundant, that is pipe which are no longer needed. So pipelines must be eliminated. So if a pipe is not needed, then that must be eliminated, which could be at times up to 10 to 15% of the length, and this could reduce the steam distribution losses significantly. So if pipe is of no use, then you should remove it. So these are the main losses in pipe steam distribution system. So we will also see how we can improve this system. So next is steam trapping. So the purpose of installation of steam traps is to obtain fast heating of the product and equipment by keeping the steam lines and equipment free of condensate, air and non-condensable gases. So what is the use of this? So the use of this is to keep the lines free from condensate. So if a condensate has occurred, so that has to be removed, then air and non-condensable gases. If there are some gases which are non-condensable, so these three things is to be removed. So steam trap, what is it? It is a valve device that discharges, means removes condensate and air from the line or piece of equipment without discharging the steam. So we are not taking out the steam, just condensate and air is getting exited. As it is formed without escape of steam. So steam is not being exited, only the impurities, that is condensate and air, is being exited. So based on our current designs, there are three basic operating principles of steam traps. They are namely thermostatic, density and thermodynamic. So we will see, this is thermostatic, density and thermodynamic traps. We will see one by one all three traps. So thermodynamic traps sense the temperature difference of entering fluid. So there will be a temperature difference of the entering fluid. So based on that principle, it will act. Then density traps sense the difference of entering density of entering fluid. In density traps, we are seeing the difference in density, while in thermodynamic traps, sense the velocity difference of entering fluid. So if velocity is different, so then based on that principle it acts. So these are the three traps. So first we will start with thermostatic traps. So these are designed to open for cool fluid, to open for cool fluid and close for hot fluid. The cool fluid will, for it will be open, and for hot it will close. The intention is to open for cold condensate, so or air. So if air or condensate is there, their temperature will be less compared to the steam or hot condensate. So the closure occurs when the fluid, typically hot condensate, has a temperature greater than equal to certain threshold value. So the hot temperature causes a thermostatic element a thermostatic element to move in such a manner that closes the valve head against the valve seat. So this thermostatic element will close or open the valve. So this temperature threshold value is below that of saturated steam, but actual specific temperature to open or close is different depending on type of thermostatic trap. Since air, like cooled condensate, has a temperature significantly lower than steam, thermostatic traps are generally very good at venting large amount of air. So these traps can generally vent air very efficiently. So basically there are three types of traps. First is expansion trap. So expansion trap elements have internal filling that expands and contracts with the temperature change to actuate valve, but filling does not vaporize. So in expansion trap, there are internal fillings, so which will expand and contract, and due to which the valve is being operated. Then balanced pressure trap elements have filling which is mixture of water plus minerals, water plus mineral spirits that generally vaporize or condenses at near to steam temperature to actuate the valve. So this will vaporize to actuate the valve. Then there is a bimetal. So as you know, bimetal trap elements are composed of two dissimilar metal strips that are bonded together so that temperature change causes deflection in one direction. So it will cause deflection in one direction or its opposite to actuate the valve. Then next is density traps. So these are designed to open for more dense fluids and close for less dense fluids. So in density traps, it works on the principle of density. So the intention is to open to discharge condensate and close for the steam. So the opening and closing of the valve mechanism occurs by the using the buoyancy property of floating object. Buoyancy. So the buoyant object might be sealed, round or oblong float, inverted bucket or open top bucket. So due to principle of buoyancy, it works. So there are two basic categories of mechanical traps that operate on the density principle. That is float and bucket. So they are classified here in four categories. There is lever float, free float, inverted buckets and open bucket. So first, lever floats. So it contains a spherical oblong float attached to a lever mechanism. So the mechanism uses the buoyancy of the float magnified by lever arm length and fulcrum point So lever arm and fulcrum point is used to open the valve. So this will open the valve and close the valve. So they close by combination of lever mechanism weight and net system pressure acting on the valve head. So lever arm mechanism is used. Then there is free float. So what will happen in free float? So this free float also consists of a spherical float, uses this buoyancy to open by cantilevering of the top edge. So by cantilevering of the top ledge of the valve block. So they close by combination of float weight. So by the combination of float weight, condensate level, net system pressure and mechanical stop mechanism are used for free float. Then inverted buckets and open buckets. So in inverted buckets, an inverted cylindrical shape bucket which is open on the bottom side. So an inverted bucket is used which is open on the bottom side. It gains buoyancy to close the valve when the steam or air enters. So when it enters, it closes the valve. So they open by combined effect of levering the bucket with and cantilevering of the valve block. Then there is open bucket. So open bucket contain a cylindrically shaped bucket that is open on top side. So in this open bucket, the cylindrical is open on the top side, and the mechanism uses buoyancy of float to keep the valve shut, and the condensate fills the bucket. It will fill the bucket to remove the buoyancy, so thereby opening the valve. So these are mainly density traps, so which are used to operate the valve. So then there is a thermodynamic trap. So this thermodynamic trap, so we will see this trap in the next lecture. We will also again revise this topic once again. So thank you very much.